Okay, I'm Dr. Lo. I'm graduate from UTM. I get my PhD at 2018. Okay, so I'm teaching physics. So year 10, year 11, and year 12, which means that A level, I'm mainly teaching in physics. So my teaching experience is 8 years. Okay, now entering the 9 years, the nine. Okay, so basically IGCSE is not that difficult. Okay, so today we will start with a very simple topic. Let me show you the slide. Hold. Okay, here. Okay, now I think you can see the slide. So basically, we will sit for three papers. Okay, now basically we will take paper 2, 4, and 6. Okay, paper 5 is depends on the school. Maybe they want to do the practical, so you need to hands on. But we are taking the alternative to practical, so we answering the paper. Okay, so paper 2 is the multiple choice. Paper 4 is the theory. Structure question. Paper 6 is practical. Actually, paper 2 and 6 is much more easier to score. Okay, paper 6 is you just follow the questions, instructions, and then some technique we can know, then we can solve the problems. Okay, mainly at this part, paper 6, we can score very high marks. Okay, then paper 2 here is 40 questions. The times only allocate 45 minutes. So actually, it's very, very fast. Which means that maybe one questions you only get less than 1 minute to complete it. After that, you need to left the time to check your answer. Okay, the hardest part actually is paper 4 lah. You have to write the theory, you have to know, have a very strong knowledge and so on. Okay, so in our year 10, basically this according to this Cambridge book lah, textbook. Okay, so year 10 we have to study until chapter 15, the electromagnetic spectrum. Okay, so all these are the topic that we are going to learn in year 10. So today we will talk about making measurements. So it's very simple. We start with very simple topic. Okay, so at here another starting from chapter 16 until chapter 25. This is year 11 syllabus. Okay, so roughly this is the idea, give you some idea about what we are going to learn. Okay, so I'm going to share the slide. Okay, let me for a short while. Okay, boys and girls, right now we are going to start with our the topic chapter 1, measurement. Very simple, just do not do any careless, will do. Okay, first we learn about measuring the length and volume. Okay, so length can be measured using the unit. The common unit is actually cm, m, km. Okay, so we write it down. So at here, centimeter. Okay, cm, quite common we use. Okay, you take out your ruler. Actually, we are measuring using ruler is cm, 10 cm, 15 cm. Okay, then after that, meter, m, kilometer. If longer distance than kilometer, km. Okay, here I want to emphasize meter is the SI unit, System International Unit. Okay, so this is SI unit, m. Okay, instrument to measure the length. So if we want to measure the length, there is a lot of instrument, but in our year 10, we mainly focus on meter rule. Okay, in the lab, your teacher, when they doing the experiment, they will give you the meter rule to measure the length. Okay, meter rule. Meter rule can measure up to 1 meter. Okay, up to 1 meter. Then one more, if you want the distance to be longer distance, okay, let's say you want to measure the length of the classroom, cannot using the meter rule because 1 meter is not enough. So we can using measuring tape. Okay, so this is measuring tape. Okay, beside the measuring tape, this is ruler, meter rule. Okay, so this is measuring tape. This one can be measured more than 1 meter. Sometimes it's 3 meter, 5 meter, 7 meter, 15 meter. Okay, it depends on the measuring tape. Okay, so this is measuring the length. Okay, precision, which means that smallest unit of the instrument. So for the meter rule, if you take the meter rule in the lab, actually you go through, okay, here we also can see. Okay, can you see that at here? The smallest value that we can read at here basically is 0.1 cm. Okay, you'll get 0.1 cm. So this is the smallest unit, smallest reading that we can get, smaller scales that we can get. So at here we write down 0.1. So the precisions for the meter rule is 0.1. Okay, if we convert to mm, it will be 1 mm. Okay, when we taking reading, the most important, trying to make sure your eyes perpendicular to the scale. Okay, so this sentence, eyes must be perpendicular to the scale. Perpendicular at here means that 90 degree. Your eyes is 90 degree. So can you see that this is 90 degree? Okay, this part, 90 degree. Here, 90 degree. This is the correct position. Okay, if you're using others position from the left, from the right, okay, from some way, okay, it's not perpendicular, the reading that you take will be inaccurate. So when we taking reading, please we make sure our eyes perpendicular to the scales to avoid, we call it as parallax error. Okay, to avoid parallax error. Parallax error is the error due to the wrong position of your eyes. That is called parallax error. Okay, so most of the time they like to ask in the paper 6, they like to ask you how and what is the precaution step that you can take so that you can take an accurate reading. Answer is eyes perpendicular to the scales of ruler to avoid parallax error. Okay, so this one you tick, this is the correct position. So this one, cross, this is wrong position of your eyes. Okay, so you see, in the different position, the reading that you get will be different. Okay, maybe I measure, I say that, hey teacher, this object, the length is 1.9 cm. But your friend, best friend, just sitting beside you, no, I saw it is 2.1 cm. So two of you giving the giving the different answer. So at the end, who are the correct one? The person who are taking perpendicular to the scales, that is the correct one. Okay, so next goes to the next page. Okay, if let's say we want to measure the length of a curve, we cannot using ruler, okay, because it is a curve. So what should you do? You're using the string, follow the curve line, then you know the length, then you're using the ruler to measure the length of the string. Then you will know the length of the curve. Okay, this one seldom asked. So far, I didn't saw any question. Okay, measuring the diameter of the object. If let's say the object, is round, okay, how can we make sure we're able to measure it correctly? So we can using a block, two block beside it. Okay, these two block will be fixed the metal ball. Okay, fix the metal ball. In this diagram, they're using set square to fix it. Okay, you don't want to using set square. Actually, we can using two block beside it, fix it. Okay, then after that, from here we can measure the length, measure the diameter. Okay, this is the correct way how we do measurement for the round object. Okay, so now we are coming to the past year questions. So you look at the question number 1. This is 2016 past year questions of our IGCSE. Okay, this is an enlarged drawing at the of the end of a ruler. It is being used to measure the length of a small feather. What is the length of the feather? Okay, boys and girls, I want you type your answer in the chat box, but don't type to Dr. Low, the one, because Dr. Low is the iPad that I use for me to write something. So you can type to the Newton Scholar or you type at the public. Okay, you type your answer. Okay, answer is A, correct. Okay, I saw the answer. Thank you. Thank you for responding me. Okay, so from here to here is 19 mm. Look at this. This is mm. Okay, this is mm. So the unit will be mm. Okay, we goes to the second question. Okay, read it and then type your answer to me. Instrument, okay, measure the length. If very small length, okay, for example, the diameter of the copper wire, we can using micrometer screw gauge. Okay, one of your friend asking micrometer screw gauge. Yes, we can using micrometer screw gauge as our instrument, but this instrument, micrometer screw gauge, this instrument is not included in your syllabus anymore. Okay, few years ago, this instrument already take out. Okay, so in A level, we will learn again regarding this micrometer screw gauge. That's why right now we didn't mention. Okay, micrometer screw gauge is the instrument to measure a very small length. Okay, okay, answer is C. Correct. Thank you. This is 4, 2, 4, 6, 8. So here, half of it, this is 9. 9 minus 2, so it's 7.0 cm. Okay. So in our IG, we will make our final answer 2 to 3 significant figure. Okay. We'll make it 2 to 3 significant figure. If let's say this is not a multiple choice, this one is asking you to do calculation by yourself. If you write 7 cm, we will give you wrong. Okay, we want two significant figure. Answer should be 7.0 cm. So can you see that 2.52 significant figure, 3.5, 7.0, 9.0. So we will make our final answer 2 to 3 significant figure. Of course, this ruler we cannot go to the 3 significant figure. Okay. Okay, next, like boys and girls, next question. What is the radius? Okay, next question. What is the radius? Hmm. Yeah, I saw your answer. Yes. Okay. Radius actually mathematic. Now it's talking about something like mathematic. Okay. Radius is here. Okay. So at here 20, then this part is 1, 2, 3, 4. Okay, so here is 4. 20 minus 4 is 16. So we got two ball. Okay, one ball actually will give you xcm. So radius is half of it. Okay, so xcm divided by 2, actually you will get 4.0 mm. Why mm? Because this ruler giving mm scale. Okay, so at here, this one is radius, here is radius, here is radius, and radius. So you want to using 20 minus 4 divided by 4 radius, also get the same answer, 4.0 mm. Okay. Okay, dear, next. Number 4. Do it. Number 4, and then you tell me your answer. Hmm. Okay, type the answer in the chat box so that I know that you're already done. Then we can discuss and we proceed. Must respond me. Others, what is your answer? Number 4. Yeah, now I saw your answer already. Starting. Good job. Okay, good job. So at here, I think you guys are very smart students. Okay, you doesn't being tricked by this question. So this one should be 4.2 cm. This is 3.5 cm. Okay, so 4.2 is because from here to here is already 4. Okay, So this one, we go back here at the front, we got two scale, okay, small box here, so it's 0.2. So add it up together will be 4.2. 4.2 times 3.5, actually it will be B. Answer will be B. Okay. My boys and girls, goes to the questions number 5. This is 2004 questions, past year questions. Okay, a piece of cotton, okay, between 2 points on a ruler. What is the length? When the length of the cotton is wound closely around a pen, it goes round 6 times. What is the distance once round the pen? Good job. Okay. If I saw your message got 4 to 5 students, then I assume most of you actually is already complete. Okay, here the length at here, this one is 15.6 cm. So this one is at 2.4 cm. Okay, so the length actually will be 15.6 minus 2.4. So you will get 13.2 cm. Okay, one round. So you have to using 13.2 divided by 6. So you will get 2.2 cm. Very good. Okay. So we go to your next question. Use the ruler in the figure 1.1. Find the length of the piece of cotton. Type your answer in the chat box. I just noticed that actually they recycle the diagram, you see. This is 2013 questions, the diagram. It's the same as just now what we did at here, 2004. They recycle the diagram. So the answer is actually same like just now what we calculate at here, 13.2. Okay. If we do more multiple questions, we will find that some of the questions they will keep on repeating. So if we do more past year questions for paper 2, actually sometimes we can score very high marks for that paper. Okay, so this one, if 2 mark, please, although it's a very simple questions, you look at it, you press your calculator, you will get the answer, but you have to show working step because here is showing you 2 marks. Okay, so do not skip any working step. 15.6 minus 2.4. So you will get 13.2 cm. 13.2 cm. Okay. 2 to 3 significant figure. So at here we're using 3 significant figure. Is fine. Okay. The left hand end of the cotton is moved to the 1 cm mark on the ruler. Okay, so we move this to the left. On figure 1.1, mark clearly and carefully with an arrow where the right hand end will reach on the ruler. So what do you think? What is your answer? Where should I put my arrow? On my right hand end. Okay, so we move the cotton to the 1 cm mark. Now your right hand end, actually it will be placed at what position? Hmm. How about others? How about others? Do you able to solve it? Or struggle with this question because only 2 students typing your answer? Okay, so I think should be fine lah. Okay, dear. Here, if you put at 1 cm here, okay, you start from here, 1 cm. So you ask yourself, okay, what is the length of this piece of cotton? So just now we count and we get 13.2. Now we place at 1, that means that this 13.2 cm, we plus 1.0 cm, then 14.2 cm. So which means that 14.2 here. Okay, our arrow should be placing at here, 14.2. Okay, so this one, when you move your cotton to the 1, so you're thinking starting from 1, so plus the length of the cotton. So the length of the cotton just now we already count is 13.2. So at the end, we place our right hand end at 14.2 cm. Okay, so this is the correct position. Okay, we goes to the next one, C. Okay, do it. The piece of cotton is wound around the wooden rod. The rod has a square cross section. Okay, the cotton goes around the rod exactly 3 times. So can you calculate the thickness of the square wooden rod? Like you very smart, huh? Yeah, I think you are a very smart boy. How about others? Try. It goes 3 rounds. How about others? Are you with me? Okay, Megan. Yeah. Licious. Licious. Oh. Okay, dear. Here answer is 1.1 cm. You guys are very clear on what the question want. Okay, here. This is how thick. Okay. So at here, we should using 13.2 because just now the length is to 13.2. Okay. So we should divide it by 3 rounds. So 1 round, okay, this one answer will be 4.4 cm. This 4.4 actually is goes like this, 1 round. Okay. So if I want this thickness, okay, so 4.4 cm, I should divide it by 4. So I will get 1.1 cm. So this one is 1.1 cm. So this one is 1.1 cm. Here is 1.1 cm. So this one also 1.1, 1.1. Okay, why I know? Because here just now they got mentioned this is square, square. Okay, the side will be the same. So this one no problems. Then we go to your next page, page number 5. Okay, length quite easy. Okay, so we goes to measure the volume. Okay, we want to measure the volume. Volume can be measured using the unit. Okay, normally we will say cm mq, ml, l. Okay, all are can be the unit of volume. Okay, so here cmq, okay, mq, ml, or L. Okay, if water, then we can mentioning it in liter. Okay, but then if let's say we say how we say 500 cm cube to describe the volume of water, also no problem. Not necessary must be in ml or L, liter. Okay, can be using cm cube or m cube to describe the volume of water, doesn't matter. Okay, we want to know the volume. So we got 2 cases. One case is if the object is regular shape. If regular shape, that one is easy because we got formula, okay? In mathematics, we learn formula for the volume. So for the instrument, we using ruler, measure the side. For example, this one, the rectangle here, okay? Volume is the length. We can using the length times width times the height, okay? So at here, we can using 2.0 times 2.0 times 1.0. So at here we'll get 4.0. Unit is cm Why cm dear? Because this is cm, here is cm, here is cm. 3 times cm, 1, 2, 3. So we need to have cm. Okay, can you see that? I write 4.0, not 4 cm. Okay? So this one easy. So you have to know some formula for the regular shape, okay, to calculate the volume. Okay. So at here, volume for irregular shape. If let's say I give you a stone, the stone is not sphere. So how can I measure the volume, teacher? Actually, this method we call it as water displacement. Okay, this method we call it as water displacement. Okay, so how we measure? We can using measuring cylinder. Okay, so we pour the water until a certain volume. The volume is easy to read. Okay, for example, let's say at here you can having like 50 cm cube. Okay, for example, 50 cm cube. Then after that, you put the stone or you put whatever irregular object into the water. Of course, the water will go up. Okay, so this one is called water displacement. So the water level will go up. When it goes to here, maybe this one is like 60 cm cube. Okay, so at the end, I know that it increased 10 cm cube. This 10 cm cube, where it come from? From the volume of the object. Okay, from the volume of the object. So that's why it increased. So using this method, I can know the volume of the irregular object. Okay, so one more thing I want to emphasize at here is, can you see that the position of the ice? Okay, this one, the position of the ice. So at here, this one ice is perpendicular to the scale of measuring cylinder. Okay, 90 degree to the scales. Can you see that? 90 degree. This one 90 degree. Okay, 90 degree to the scales. So this is the correct position. You don't look at here. Okay, lazy. Then you look at here to read the reading. So you will get the wrong answer. Okay. So second point, later on we'll touch. Later on we come back here. Okay. Teach you another technique to read it correctly. Okay, so this one is the volume for the irregular solid. We're using the new volume minus the initial volume. So we'll know the volume of the irregular object. Okay, another one we can using Eureka can, or we call it as displacement can. Okay, this one is initially there is some opening at here. Okay, some hole here. Then we pour the water until it's exactly at this point. Okay, once you added it in, so the water will displace out. So this is the water displace out. That's why this method called water displacement. Okay, so the volume that come out at here, we can measure. Okay, we take the reading. Okay, measure the volume of the water being displaced out. So at here, we will straightly know this volume actually is straightly the volume of the irregular object. Okay, see, volume of the object equals to volume 5. Okay, so at here, we goes to your next page, page number 6. Okay, we go together. Okay, this is the second point that I want to emphasize at here. When we're using measuring cylinder, first, our eyes must be perpendicular to the scales. Okay? Second, you should look at the top of meniscus or bottom of meniscus. What do you think? Like boys and girls, type your answer in the chat box. In your sense, okay? What do you think? The top or at the bottom? We got two answers. How about others? Do you think that we're using the top or bottom? How about others? Only one bottom. The rest mentioning the top or two. Okay, Emily also mentioned bottom. So what is the correct answer? My answer is bottom. We should look at the bottom of meniscus. Okay, we should look at this part. Okay, this reading. We should take this reading. Okay, that means that here. So can you read it and then tell me in this diagram the correct reading should be, volume of the water should be how many? No? Yes. Yes. Huito and Emily is correct. Dear, draw your line at here like this. Okay? Showing that this is the position of your eyes. Showing that this is the correct position of your eyes. Okay, this reading actually is 47 cm cubed. Okay, I would like to write 47.0. Okay, because this smallest scale at here, the smallest at here, actually we can take 40.5. So that means this is 0.5. That means one decimal place. So at here, we should write 47.0. Okay, 47.0. Do you get what I mean? This one to this one actually is 0.5 cm cube. So one decimal place. Okay, one decimal place. So my answer, I will write 47.0. Okay. So next, okay, so I come back just now the one here. When we take the reading, eyes must be perpendicular to the scales. Second one, look at the bottom of meniscus. This is a very common question asking in your paper 6 alternative practical. Okay, they will ask you, can you describe the precaution step to make sure you get a accurate reading? Okay, so they might be asking you, you may draw the diagram, okay, helping you to explain. So we will draw the position of your eyes perpendicular. So I will draw like this, something like this. Okay, of course the measuring cylinder we will draw complete lah. Okay, complete diagram. Then your eyes position is this. Then we were mentioning just now the 2 point as perpendicular to the scales of measuring cylinder. Look at the bottom of meniscus. Okay, so we look at here. Which one is the correct eyes position? Perpendicular. Okay, so boys and girls, left hand side or right hand side? Which one? Left hand side or right hand side? This one I confirm wrong. Okay, no need to look at it. So left hand and right hand is perpendicular. But left or right is the correct position? Type your answer in the chat box. Thank you. Left hand side, yes, here. Okay, here. Then after that, okay, there is 1 year's past year question. They're asking you, why we take the bottom of meniscus? They will say, why they take the reading of bottom of meniscus? Why not the top? The answer that in the answer scheme is because this part, can you see that this part? The amount of water is very small amount until we can ignore it. Okay, so we take the bottom of meniscus reading here. It's because this part, the amount of water actually is very small amount, so we can just ignore it. Okay, my boys and girls, we go to the next page about density. Okay, density formula is density equals to the mass divided by volume. Okay, sometimes if we don't want to write so many words, okay, we can using symbol to represent this formula. Look at this, this is the symbol. This is the symbol for the density. This is symbol for density. it is not called as P. It's not called as P. So you look at me, this one. If P, I will write like this. But this is like this, rho. Okay, like this. Wait. Okay, like this. This is not P. This one, if we pronounce, we call it as rho. Okay, this is called rho. It's a symbol for density equals to mass divided by volume. Okay, if you want to using for symbol to represent the formula, we can write in this way. Okay, unit for density. Basically, we don't need to memorize, dear. We don't need to memorize. Physics is we study smart, okay? We can get the unit from formula, okay? Why I say so? So you look at this, mass. We can think about mass. Mass unit is in SI unit. Now I'm talking about SI unit first. SI unit, that means that System International Unit. Okay, mass will be in kg. Volume, it will be in meter cube. So kg divided meter cube, we will get kg per meter cube. So this is the unit for density. If you don't know how to derive, then you have to memorize everything. So that one will kill your brain cell. Don't want. Okay. So if teacher, my object is very light, I don't want to using kg. Can I using gram? Of course, yes. Okay. Or gram. Then gram will always pairing with cm cube. So or gram per cm cube. As long as they didn't asking for SI unit, you can write your answer in gram per cm cube or kg per meter cube. Okay? Unless they mention they want SI unit, then no choice, we have to convert. Okay, look at here. We want to measure density. Of course, we need to measure the mass. Okay? We need to measure the mass. We need to measure the volume. So what instrument we use to measure mass? Any of you know? Type in the chat box. Mass. How you measure? Do you know what is this? What we call about this? In the lab, we will have having this kind of instrument to measure the mass. Yes, thank you. Okay, here. This is balance, okay? Electronic balance or balance. Normally, we just mention balance. Okay, we need to know the volume. If the volume is a irregular shape, we can using just now the method which is called water displacement method. Okay, so what instrument we use? We can using measuring cylinder. If this is a regular object, for example, like this, what instrument we use? Easy, because we're just using mathematic formula. But I need to know the width, the length, the height. So we're using meter rule to measure it. Okay, meter rule. Okay, we not writing ruler also never mind. Meter rule also correct. Okay, boys and girls, look at this example. Density is mass divided by volume. So I measure the object, then I also put it in the water. So can you do calculation and then tell me what is the density of this stone? Let's say this is stone. Okay, I don't know is it a stone. So you just measure the density. So basically, if this is the unknown object, we can calculate its density. After that, we go to the online and then we search. If this is 0 point something, okay, what is this object? Basically, material of the object. Then based on the density, we can having the reference, then we will know what is this. Okay, if let's say this is unknown material, so we calculate the density. Okay, do calculation and then tell me what is the answer for this density. Hmm? Really? I need to find my calculator. My answer is different with you. Oh, really? Well, let me check. Oh, okay, okay. Okay, okay, okay. Yeah, 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 yeah. Okay, okay. I know. Yeah, correct, dear. Because I make it two significant figure. Okay, here 55 gram divided by the volume is 31 minus 24. So this one, gram always pairing with cm cube. So in our lab is cm cube, measuring cylinder. Okay, so this one cm cube. So the answer, your friends, is 7.86 gram per cm cube. In physics, there is no fraction in your final answer. Do not write fraction 1 over 2. Final answer, then you will lose the mark. You need to convert it into decimal, become 0.5. This is the correct way. Okay, just now I thought you are praising wrongly. It's because I using 7.9, two significant figure. Now three significant figure also no problem. Okay, so how about others? Okay, if okay, then we proceed. Okay, it's actually just take this reading. Mass, this is mass. Then this is the water displacement, is the volume of the material. So if you go to the online search, roughly X gram per cm cube, what is this material? Then you will know what is this. Okay, the material of this object, irregular object. Okay, here, look at this, the density. Okay, they tell you the density. So from here, all this reading, we will find out that if they float on the surface, at the highest, at the top, actually, their floating is because their density is actually low density. Okay, so we say that less dense. Okay, if less dense, then they will be float. Okay, the mercury is 13.6 gram per cm cube. So this one it will sink is because denser, or we say higher density. Okay, so you have to know how they arrange. Okay, so at here, based on the density, then you need to know lah. Okay, this one should be at the upper layer and so on. Okay, so here, lower density, it will float. Okay, higher density, it will sink. Okay, like boys and girls, we goes to the past year question 2011. This one finish writing. If I'm too fast, any page you haven't write it yet, then I already go to the next page. Then you have to type in the chat box and ask me to go back. Okay? So boys and girls here, let's do this question. I want you to calculate this object, the density of the object. Megan, yes, correct. Very good. How about others? Do you able to get the answer? Answer is A. Like Megan type here, answer A. Answer A is correct. Okay? Density is mass divided by volume. Look at the balance. You see, these instruments we call as balance. Okay? So balance is 7.2 gram divided by the volume. How do I know the volume? Because this is cube. Dear, this is cube. If cube, that means that they were having 2 cm, 2 cm, 2 cm here. Okay, length times width times height, all are 2 cm. So 2 times 2 times 2. The unit for volume will be cm cube, is because 2 cm times 2 cm times 2 cm, 3 times cm. So your answer should be 0.9 gram per cm cube. Answer is A. So this question, they want to test you. Do you know how to calculate the volume from this cube? Okay. So here, next question, like boys and girls, I want you to do calculation to find the density of this liquid. What is the density of this liquid? Do it. Let's just redo. Not D. Like Hern Yu? No, not A. Ah, we told Megan, Emily, and now Lai Hern Yu also doing the correct answer. Answer should be B. Okay, answer should be B. How you do calculation? Density equals to mass divided by volume. So the mass, you look at this. Why they need to measure the mass for the empty measuring cylinder? This is because when you pour the water in, you measure the mass. This 250 gram is not only the mass for the liquid, it's still including this measuring cylinder. So before we doing this, we have to measure the empty one. If you think that, oh, teacher, I forget. I already poured the water in. So I measure 250 first. Oh. Then after that, I pour out the water. I measure again the empty one. Actually, this procedure, okay? The procedure that you do is wrong procedure already. Why? Your result will be inaccurate because when you pour the water in already, then after that, measure 250, you pour the water out, you measure here. Your answer maybe it's possible you will get more than 200 grams, slightly more than 200 grams. It's because some of the water may be still here, inside here, the wall of the measuring cylinder. So the correct procedure is the empty dry measuring cylinder, you measure the mass first. Okay, so at here, 250 minus 200 divided by the volume. So if based on here, it's 25 cm cube. Answer will be 2 gram, 2.0. Okay, 2.0 gram per cm cube. Okay, like boys and girls, we go to our next page. Question number 3. Try to do the questions. Now, starting is empty regular box. Okay, here, starting is empty regular box. Then after that, same box filled with liquid. The box has a mass of 60 gram when empty. Filled with liquid, total mass is 300 gram. Density of the liquid is 1.2. What is the volume of the liquid in the box? Now, not asking you to get density. They give you density. Do you know how to find the volume? How about others? Do you able to count it out? Think about the density of liquid. So this is liquid, mass of liquid, volume of liquid. Now we're all talking about liquid. Yeah, I saw 3 of you answer the correct answer, get the correct answer. Okay, boys and girls must be very clear on what you're calculating right now. Density of liquid. So of course the mass must be about liquid, volume must be about the liquid. So at here, this is 1.2. This is 1.2 gram per cm cube. The mass of liquid is not 300 because this 300 include your box. So should be 300 minus 60 gram divided by the volume. Okay, they want you to calculate the volume. Okay, so at here, 1.2 V equals to 240. V is equals to 200 cm cube. Answer is B. Okay, is it okay? Okay, then, boys and girls, you try with question number 4. Okay, so we have a measuring cylinder containing the water. Show the same measuring cylinder and the water after 10 identical solid glass sphere has been added in. The mass for one sphere is 10 gram. What is the density of the glass from which the sphere are made? Okay, what is the density of the glass? How about others? How about others? Now I only collect two answer from you. Okay, have to respond me so that I know that most of you already complete, then we can proceed. Okay, so at here, mass of 1 is 10 gram. Okay, so at here, density is mass divided by volume. Now, mass for one sphere. Okay, volume for one sphere. We should know this about this. Okay, the mass is 10 gram. How about the volume? So this one is 70 minus 30. That means that the volume for 10 actually is 70 minus 30. So it's 40 cm cube. Okay. Then after that, we're having a look. Volume for 1. How about volume for 1? Now we got total 10. So we should divide it by 10. So you will get 4 cm cube for 1. Okay, volume for one sphere actually is 4 cm cube. So your answer should be 2.5 gram per cm cube. Answer should be C, okay? If no question, we go to your page number 10, 2011 past year question. All the exercise that I included is past year question. So we are learning and then we really practice with the past year question. Okay, we get ways to know how they want to ask in your exam. Okay, 2011. Okay, what is the volume of stone A? Easy. If not mistaken, this question should be 2 marks. So do not skip the working step. Okay? So write the working step and then tell me. You just tell me your final answer. But you have to write working step in your worksheet. This question easy. Megan already give the answer. Yes, teacher, can you show question 4? Yeah. Question 4. Okay. Volume for one sphere. One sphere. So this is step 1. This is step 2. Yeah, correct. Megan, Lai, Yu, and Hui Tong, your answer is correct. So you can continue whilst we're waiting for others to complete the question 4. So you may try with B and C. C, think properly. Think properly. Alex is okay already. You let me know. So I turn back to the page 10. Okay. So just now, Hui Tong them give us the answer about 16.2. 2 mark. If the question is 2 mark, please, okay, I want you to show working step 60.4 minus 44.2. So you get the answer 16.2 cm cubed. Okay, for example, this question, if let's say it really doesn't give you the what? Give you the unit. So you have to write the unit 16.2 cm cubed. If you didn't write the unit, most of the time we can deduct your mark. But of course, it depends on answer scheme. Sometimes they feel that want to pity on you guys, so no unit, they're still giving mark lah. But most of the time, they want you with the unit. Okay, have the unit. Okay, B question. The mass of the stone is 40.5. Calculate the stone. I calculate the density of stone A. Right, boys and girls? Tell me the answer. Okay. Yes, correct. 2.5. Okay, boys and girls, if let's say this question, it can be give 3 to 4 marks. This kind of question, they can give 3 to 4 marks. Okay, if 3 marks, how they give the mark? how they allocate the mark. Okay, so I want you, as long as whatever calculation they give above 2 marks, okay, 3 to 4 marks. First, you have to write the formula. Formula will give you 1 mark. Okay, formula will give you 1 mark because in your IG, they didn't provide formula list, so they expect you memorize all the formula. So one of the advantage at here is formula will giving you mark sometimes in the working step. Okay, then this one is 40.5 divided by the volume. The volume for the stone A, just now we already calculate 16.2. So your answer will be 2.5 gram per cm cube. Okay, if 3 marks, how they give the mark? Substitution correctly, they give 1 mark, another 1 mark. Oh, I write 1 here. Okay, final answer, they give 1 mark. Okay, this kind of question, they might also giving you 4 marks. If 4 marks, where is another 1 more mark? They will give you unit as another extra 1 mark. That means that the 2.5 final answer is 1 mark, then the unit is another 1 mark. But if 3 marks, you write 2.5 without unit, the last mark they can deduct you. Okay, so like this, they didn't give you the unit here in the column here, so we must write 2.5 gram per cm cube. Okay, for this question, they can give 3 to 4 marks. So remember, formula, substitution, final answer with unit. Okay. So next, stone B. Just now we calculate stone A. Stone B have the same rock. Okay, same material lah. Okay, so I write it here, write same material. They are same material as stone A. But now stone B is larger volume. Stone A is removed from water, then we place the stone B in. The measurements are then repeated. Which of the value in the experiment will be different when you're using stone B? Okay, what value will be changed? So type your answer in the chat box. Let me know. So you just tell me that is volume or mass or density. Which one will change? This question is 2 mark, dear. This question is 2 mark. So that means that you got 2 answers. How about others? This question I also want more answer. I want more students give me the answer. Tell me the answer. Not only got 2 of you give me the answer, how about others? 3 of you? So far until right now, none of you give me the correct 2 answer is correct, both correct. So I give you the answer. I tell you the answer. Okay, the answer at here is the volume will change. Of course, it's larger volume. So volume will change. It will be bigger than 60.4 cm cube. How about another one? My answer is mass will change. Mass will change. Okay, how should I tell you? Okay, for example, you look at me. This is ruler. Not ruler. This is eraser. Okay, my eraser here. I cut it into half. Okay, when I cut it into half, my volume will decrease. My volume will decrease. My mass also decrease. My mass also decrease. This one eraser is from the same material. If I cut it into half, my volume will decrease. My mass, I put it on the balance. Of course, the mass will decrease also. But density will be remain unchanged. That's why I want to highlight the keyword same rock. Then you write same material. Density is mass divided by volume. If the object, the mass, the volume increase, of course the mass will increase. Just now small rock like this. Now it's bigger rock, but they are same rock, same type of rock. Like what I give example just now, my eraser, same material, I cut into half. Okay, the small part, I go and measure using balance. Of course, the mass will decrease. But why teacher density will not be changed? They are all here. You write down same material, same density. Okay, do you guys know what is the density for water? Any of you know what is the density for water? How many gram per cm cube? Guess. If you don't know, you may guess. How about water? Yes, correct. You know that. 1.0. 1.0. Okay, 1.0. Today, you holding your water bottle, 500 ml comes to me. Teacher, what is the density for water? I will tell you, oh, this is 1 gram per cm cube. Then later on, another friend, bring a bigger water bottle, comes to me. Teacher, how about my water density? I still telling you, this is 1 gram per cm cube. The density for the material, as long as they are the same, so their density will be the same. Okay, their density will be the same. What is the meaning of 1 gram per cm cube? Every 1 cm cube, okay, it will having a mass of 1 gram. Every 1 cm cube, the volume, the mass will be 1 gram. This is a fixed value for the material. Okay, so in this question, I want to emphasize when you are mentioning about same material, same rock, okay, same, they say that, hey, stone, this is copper wire. I take another copper wire. You see copper and copper, they are same material, their density will be the same. Okay, so volume increase, mass increase, but density still remain unchanged. Okay, so if no question, we go to your page number 10. Okay, we go to your page number 10. Easy. 2012. State the equation linking the density with its mass and volume. Okay, dear, I don't want you write in this way. Don't write this as your answer, then finish. If you write in this, the examiner don't know which symbol you want to tell us. Okay, what is this symbol? What is this? What is this? Okay, so if this kind of questions, we need to using the word. For example, we say density equals to mass divided by volume. Do not just write the formula only with the symbol, okay? With the symbol. If you want to write in the symbol, you still need to tell me rho equals to density, mass equals to mass, m equals to mass, v equals to volume. Only you able to score the mark. Okay, boys and girls, we look at the B questions. When oil leak out, okay, when it leak out, it form a very thin layer of oil, okay, on the water. So one of the oil actually they call cover by 2.5 times 10 power 4 by 6 times 10 power 3. Okay, then the thick is 3.0 times 10 power of negative 6. Can you calculate the volume? Calculate the volume and tell me what is the volume. Rectangular area. So they give you the area, they give you the thick. What is the volume? Correct. Thank you. Volume, don't forget, is area times the height. Okay, area times the thick. So at here, 3 mark. Dear, see 3 mark. How we score the 3 mark? Please write formula. So we can say the length times the width times the height, like this, 1 mark. So equals to 2.5 times 10 power of 4 times 6.0 times 10 power of 3 times the thick is 3.0 times 10 power of negative 6. So here your answer will be 450. What is the unit? Do not forget the unit. This is m cube. But here they already give you m cube. So it's okay lah. So as long as your final here, 450 m cube. 3 marks, If you didn't write formula here, you will lose 1 mark. So here 1 mark, substitution 1 mark, final answer with unit 1 mark. 3 marks. Okay, the density for the oil is 900 kg per meter cube. Calculate the mass of oil in the slick. If 2 mark, you didn't write formula, doesn't matter. But during the worksheet, during our lesson, I want you always practice to write formula. Okay, when you write more and more and more, actually you are practicing and the formula will be going into your brain. Okay, so I encourage you guys write formula first, then do substitution. Okay, sometimes substitute, you didn't write formula, at the end you use the wrong value to put it in. Then when you want to come back and check the answer, you don't know where is the mistake. Okay, but with the formula, very easy, you will find out, oh, this one is mass, sorry, I put it in the wrong way, something like that. Okay, boys and girls, calculate the density, no, calculate the density, calculate the mass. It should be easy, dear. Why none of you give me the answer? Yeah, how about others? Do you able to get the answer? Practice write formula, easier for you to do checking. Okay, so density is 900, the mass we don't know. Then this one is 450. The mass actually should be 900 times 450. So your answer is 405,000 kg. Licious, check which part you made mistake. It should be 405,000. 900 times 450. 450 is the volume that we calculate just now. Okay. Careless. So if you write the working step like this, after that you come back and do calculation and checking your answer is much more easier. So have to write complete way, Okay. So like boys and girls, we go to the question number 7. A student measure the length of the coin using a ruler. Okay, this is not to the scales. You don't using your own ruler and measure it. Okay, dear? Not to scale. Okay, his measurement is 3.8 cm. There are 20 turns, so we go 20. Okay, the student used his measurement to calculate the average thickness. Okay, that means that this one from here, thickness from here to here. Okay, it's called thickness. So can you guys show me, average thickness of the wire is about 0.2 cm. So try, do you able to get 0.2 cm for the thickness of the wire? If you're able to get it, then you tell me, yes, you can get it. Okay, in total, he measured 3.8 cm. So actually, this one 3.8 go 20 turns of the wire. How about thickness of the wire? Average. Yes, you get the answer right. So what should we do? Let's say this is 3.8 cm. So in total here, actually it's 20 turns. Yes. How about 1 turns? So we should using 3.8 divided by 20. So roughly you will get the answer 0.19 cm, right? So roughly near to what they say, 0.2 cm. Okay, easy, two marks. Okay, but now the question tell you that actually the way the student measure 3.8 is not accurate. Can you give me one reason why the measurement is not accurate? Look at it and then type your answer. Why? Why this one 3.8 is not accurate reading? Maybe Not maybe. It is not 3.8. It should not be 3.8. What is the problems? Why 3.8 reading measurement is inaccurate? What do you think? Look at the diagram. Type your answer, type your idea in the chat box. Let me check. No? Didn't uncoin doesn't matter? Yes, Licia's idea is correct. There is a gap. Some part is here, there is a gap. If you look at here, yes, Megan, there is a space. Can you see that this part, the space actually is larger? This one, there is some gap here. Okay, there is some gap here. This part will cause your reading inaccurate. Okay, so here, suggest one reason why 3.8 may not be inaccurate. So we can say that the wire, you can say that there is a gap in some part of the coil can. Okay, wire not touching. Answer scheme say not wire not touching. That means that gap lah. There is a gap in certain part. Okay. Answer scheme say wire stretch in certain parts. Okay, then they also accept with the answer said that the ruler not at zero. But how we know? This answer I'm not that encouraged. Unless they're drawing a ruler. Unless they're drawing a ruler and showing they are not starting from zero. Okay, what else the answer scheme writing? Let me check. Wire overlapping. Where got wire overlapping? So I don't want. Okay, so I think this answer is the best. There is a gap. Okay, mentioning there is a space, there is a gap. Some part the wire doesn't touch. Same meaning, 1 mark. Okay, the next one, the volume of the wire in the coil is 16.6 cm cube. Mass is 14.8. Calculate the density of the metal used for the wire in the coil. Okay, do calculation and then tell me. See, 3 marks. Look at the mark and then we decide, okay? The formula, substitution, final answer. Roshuen, you can write 0.19. I will write in this way, 0.19 cm. Then I will show approximately 0.2 cm. I will show in this way. Okay, here, the last one, easy. Density is mass divided by volume. Density is the mass 148 divided by volume is 16.6. Answer. Like you already give us the answer. Do you guys get it? Okay, so at here our answer should write 8.92 gram per cm cube. So 8.92. There is a line at here. Average thickness. We can write 0.19. Okay, we write 0.19. Since they're giving the space for us to write, maybe they are not expect we write again 0.2 lah. Okay, so we show the working step, then we show 0.19. Two significant figure. Just nice. Okay. This one, others should be no problems, right? Okay, we goes to your page number 13. Settle, can I proceed? I goes to page 13. Okay, this is also past year question. Ask 4 marks, They're asking you. So we have this apparatus, measuring cylinder, beaker of water. Describe how the student can determine the volume of coil using this equipment. Oh, they want to find the volume. Okay, because this coil actually is irregular shape. We cannot using mathematic formula to solve it. Okay, so what should we do? We want to find the volume for irregular object. We should using the method of water displacement. Okay, so at here, first step. Okay, we say that measuring cylinder partially filled with water. So we get some water. Okay, so first step, we get some water in. Okay, something like this. Second step, okay? Initial volume, we record it down. You can set the volume that easy for you to read lah, okay? Initial volume, V1 is recorded. So we record, okay, for example, this one 50 cm3, okay? Number 3, so you put the coil in, okay? Coil, we put it in. So submerge in water. Okay, after we put it in, so we put it in, okay? Put it in, number 4, new reading. Of course, it will rise a bit, okay? Goes to a new reading. So number 4, new volume. V2 is recorded. Number 5, volume. So the volume of the coil is equals to V2 minus V1. I can using symbol is because just now I already defined what is V1, what is V2. If you didn't define, you just initial volume is recorded, new volume is recorded, then suddenly you tell me, hey teacher, you have to using V2 minus V1, I will deduct your mark. Because I don't know, V1, what is V1? What is V2? So if we want to using the symbol, I will check back, did you define what is V1 and what is V2? Okay, so at here, actually here got 4 marks, total 4 marks at here. Okay, in answer scheme, these two that give 1 mark. Then the rest is 1 mark, 1 mark, and 1 mark. 4 mark. If they're asking you to find the density of the coil, for the volume part, this is the part. Then mass, you say measure the mass of the coil using balance. Then number 6, you say measure the density by using the formula mass divided by volume. Okay, so if they're asking you how you determine the density of the coil, basically the structure is like this. Just the first sentence you add measure the mass of the coil using balance. Then the last sentence you add calculate the density by using mass divided by volume. Okay, done? Okay, if you already finished copying, please let me know. Type in your chat box. Let me know so that I can continue to the next page. Done, ah? Okay, so we go to your next page. It's called prefix. You know, prefix, I think your mathematics, you're also learning about this. This prefix is very important in physics. Okay, it's very important. It will be used to represent a very, very big value or very, very small value. Okay, if let's say I told you that you owe my money with this number of zero, then at the end you copy it down. How many zero I need to pay you back? At the end, you copy less 1 0. Okay, that will be cause a very big problems. Okay, so in order to prevent this kind of things, we will using prefix to represent all these zero. Okay, if this one 3, 6, 9, and 12, 12 0, that means that 10 power of 12. This is called tera. So we got total 10 prefix. You have to memorize tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. And their value you have to memorize. Okay, we write down first. Tera, giga. Giga is 10 power of 9. Mega is 10 power of 6. Okay, dear. Mega is capital letter M. It's not small m. Small m we call as milli. Okay, kilo is small k. It's 10 power of 3. Deci, this one too, I skip first. Milli is 10 power of negative 3. Micro, negative 6. Nano is negative 9 and negative 12. So basically, can you see that it's quite easy for you to memorize? 12 to 9 actually is minus 3. Minus 3. Minus 3. Okay, this one minus 3, minus 3, and minus 3. So this one very easy to memorize. Okay, deci and centi is 10 power of negative 1, 10 power of negative 2. Okay, now if your calculator with you, so most of the calculator got this function. Okay, you press 1, then on your left hand side, the second button is OPTN option. So you press, after you press 1, you press the OPTN, you press it. Okay, number 3 called engineer symbol. You press engineer symbol number 3. Inside, you will saw a list of prefix. Okay, you may choose milli. For example, I want milli. 1 milli actually is, what is the value? So if not mistaken, milli is number 1. You press 1 to choose milli, then you press equal. So look at the calculator show you what is the reading is showing you. Okay, some of the calculator, their prefix is already in the 1, 2, 3, 4 here. Okay, above the 1, 2, 3, 4, the yellow color, the one TGM, that one is prefix. Okay, that is another way how you use the calculator to show you the prefix. Because I don't know your calculator, but most of my student is using the model of the model that I mentioned just now lah. They got a button called OPTN option, so calculator can help you. Okay, if your calculator cannot help you, please memorize it. Okay, can I proceed? Going down. Okay, this one 550 example, 550 megawatt. This is what unit. This is a unit for power. Okay, so how about the M at here? M. This M actually is a prefix. What is the value? It's just now the mega times 10 power of 6. So this answer actually is equals to 550 times 10 power of 6 watt. So this one we're using prefix to represent it. Okay, when we do conversion from prefix to non-prefix, we should using times. What does it mean? Okay, for example, my prefix is kg. Okay, my prefix example at here, kg. Where is my prefix? This k, we highlight it. So right now I have prefix. I want to convert to gram. Gram is unit, no prefix. Okay, I should using times. So 1 times what? K is represent 10 power of 3. So 10 power of 3 gram. My answer will be 1000 gram. Okay, from prefix to non-prefix, from prefix to non-prefix, no prefix, gram is unit, we're using times. How about we are from the non-prefix, no-prefix goes to prefix. I want to convert into prefix. So what should we do? Just now is times. Right now should be divide. Okay, so right now I should divide. So I write 1000 divide what? This one, K is 10 power of 3. So I divide 10 power of 3 kg. My answer here, it can be 1000 times 10 power of negative 3. If I convert it from divide to times, so here positive 3 will become negative 3. Okay? So if you press your calculator, you will get 1 kg. This is, I want to teach you about conversion. Okay, conversion. Conversion is very important. In your textbook, it might be doesn't mention about conversion, but they assume that you already having this skill. But at the end, when we teach it, we found that students don't know how to do conversion. That's why I purposely add on this part. Okay, if no question, I want to turn to your page 15. Okay, we do some practice how to do conversion in physics. Okay, of course your mathematics you're also learning, but now we learn in physics way. Okay, highlight your prefix. Cm square is your prefix. The C is your prefix. Okay, the C value at here, C is 10 power of negative 2. Okay, your calculator, just now as I tell you that there is a list of prefix, but there is no inside, no no centi. So centi you have to know 0 at times 10 power of negative 2. Okay, prefix at the front. Prefix to non-prefix, we using times. So 1.5 we times 10 power of negative 2 meters square. Am I finished? My answer is no. Why no, teacher? Okay, dear, look at here. Cm square is cm times cm. So that means that is 2 times of c. What should we do? This one, you should square it because 2 times. Cm square, so I should square it. So for this answer will be 1.5 times 10 power of negative 4 meters square. This is how we convert it. You need to have this skill in physics. Okay, we look at the B, another example. 35 meters square to cm square. Okay, here. C is the prefix. Now I conversion from non-prefix to prefix. So opposite way, I should using divide. So 35 divide C, 10 power of negative 2. Again, the cm is cm square. So I should square it to get cm square. So 35 from divide 10 power of negative 4 cm square. So 35, if I want to convert into times, can. Times 10 power of, now negative 4 become 4 cm square. Okay, this is how we do conversion of unit. Okay, maybe they give you in cm square. At the end, the answer they want in meter square. So you have to know how to do conversion. Okay, this is area. Actually, volume is also the same. The difference actually is just the cm square become cm cube. Okay, so for this one, same thing. Find out your prefix. This is your prefix C. 1.5 times 10 power of negative 2. This one should be cubic meter cube because this is cm times cm times cm 3 times. So it should be 1.5 times 10 power of negative 6 meter cube. Okay, same thing like just now, exactly the same. So this one is prefix is at the back. So non-prefix to prefix are using divide. 35 divide 10 power of negative 2. Don't forget to cube it, cm cube. So 35 divide 10 power of negative 6 cm cube. Negative 2, then 3 times, okay? So you'll get 35 times 10 power of 6 cm cube. Okay? So exactly the same like just now. Now I only need to cube it. Just now is square it. Now it's cube it. Okay? Now the main thing that I want to mention at here is the density. How you do conversion for density. Okay? So at here, how we do conversion for this, I want you to write like this. 25 gram divided by 1 cm cube equals to how many kg per meter cube? Write like this. Then we solve the upper part. K is here. Gram to K. Okay, gram to kg. Okay, kilogram. So prefix is at the back. Non-prefix to prefix, we should using divide, dear, divide. So K is 10 power of 3. So divided 10 power of 3. So what divided? 25. Okay, 25 divided 10 power of 3. Okay, the second part, cm cube to meter cube. That's why just now why we need to learn about conversion for volume. Cm cube. Okay, so 1 times 10 power of negative 2. Don't forget to cube it. Okay, then you using your calculator solve this part. Using your calculator, press, solve this part. So your answer will be equals to how many kg per meter cube? Okay, so the answer, if you do it correctly, you will get 25,000. So later on, you press it and see. So for kg, kilogram per meter cube to gram per cm cube, actually also the same method. 2,700 gram per 1 meter cube equals to how many gram per cm cube? Where is your prefix? Highlight it. K. What is your K? 10 power of 3. So it's 2700 times 10 power of 3. Okay, 1 meter cube to cm cube. Don't forget your prefix is at the back. Non-prefix goes to prefix. We're using divide. Okay? 1 divide 10 power of negative 2 cubic, because here is cm cubed. Okay, if you do your calculation correctly, this answer should be 2.7. Okay, boys and girls, is there any question for our today lesson? Next lesson, we will learn about measuring the time, measure the time. That one, I think we not only learning about that, we will entering chapter 2, okay? The measuring the time will not be cost take 1.5 hours, okay? Maybe it's like take half of 45 minutes, maybe roughly like that. We are entering chapter 2. Okay, before we end our lesson, any of you having any questions? If no questions, can you type in the chat box saying no questions? Then we will end our lesson today. If you got question, you ask me right now. No question, huh? Thank you. Good job. Okay, good job. Thank you for responding me. So that's all for our lesson today. Bye bye, everyone.